Please remember to like and subscribe, and tell your friends about me. Hi, it's Fizzle The Engineer here. I've decided to go through a problem and solve it real quick and show you an example of a couple of solutions to the problem. So, the problem we're going to be solving today is, say you've been given a collection of stones. You want to identify which of those stones are jewels. Got this problem from LeetCode. I'll leave a link in the description and maybe the problem description and the actual description as well. So we're going to start off, we're going to name our jewels array J. We'll make it a string just to make life easier. So you have A in here, and then say you have capital A. This is the example given, right? And your collection of stones, in this case, let's say, is so we have letters. It is case sensitive. We have uppercase and lowercase letters that we're considering. Okay, so a naive approach basically would be to go through each of these letters and then check the entire set of letters that are in J. So we'll go through all of our stones and then check if that particular stone is a jewel, right? So I'll go ahead and implement that algorithm really quickly, and then we'll talk about the complexity and see if there are improvements that we can make. So, and I'm going to be doing this in C++. So, oh, also, the return type is just, or the return value is just going to be the count of jewels that you have in your collection of stones. So we'll return an int, right? And we'll call this num of jewels. And it takes two strings. We're going to call the one with jewels J, and the string of stones is going to be called just S. Maybe I should make this a little bit smaller so it's not taking up too much space on my screen. You feel me? Okay. So, first thing you want to do is think of the local variables that you're going to need. Clearly, you're going to need some count variable to store the amount of jewels that you find. Initially, that's going to be 0. And then what did we say our algorithm was? We said we wanted to go through all of our stones and check if that particular stone happens to be a jewel, right? So we're going to create a loop, right? So for int, let's say I equals 0, while I is less than S dot, I'm just going to say size. I believe there's also a length method on the string class in C++, but size works, so we'll just do that. Some plus plus I, that would be our update. Okay? So, what did we say we're going to do? We're going to iterate through this. So, get the current character, right? So we're going to say char cur for current equals S of I. And that, in this case, will get us an A, right? Now, what we want to do after that is compare it to every character in J. So we're going to have an internal loop. I'm just going to kneel down here to make it easier for y'all to see as I'm doing this. So we have an internal loop that's for int k equals 0. And we can use whatever we want, but if I'm using I like to use k or something that doesn't look like an I. Right? While k is less than the length of this one, right? The length of the collection of jewels, right? Then you want to say j dot size, then k plus plus, or plus plus k. It doesn't really matter in this case. It matters in some other cases, but if you have questions about that, just leave a comment and I'll explain. So what we want to do now is basically say, okay, if the current character we're analyzing here, so cur, equals the the current character we're looking at in the set of jewels. So j of k, right? Then you want to increment the count and then just break. And the reason we break is because assuming this doesn't have duplicates, and even if it did, we wouldn't want to actually count twice. So if we find that this particular character happens to match whatever character we were looking for, or we were analyzing in this set or string, then we can just break because we increment count, we know it's a jewel. And then we continue. And then at the very end, close this out. At the very end, we just want to return this count. Okay. Now, let's analyze this, the complexity of this algorithm. So, you're coming in, you're going to basically iterate over all of these. Imagine this is this string right here is of size n, it has n elements, right? Now imagine the string that represents which characters are jewels is of length m, right? M as in Mary, right? So that means for all n, you potentially have to analyze all m of the jewels to check if this particular character in S is a jewel, which gives you a runtime complexity of n times m. Not too bad, but we can do better. Can we, right? We sure can. How? Well, where's our bottleneck? If you notice, nested for loops, an internal for loop is typically going to be a bottleneck. Sometimes you can avoid it, but sometimes you can. What are we doing here? We're taking a letter from S, and then we're comparing it to every letter in J. Wouldn't it be nice if we didn't have to iterate over all M characters in J to check if the current letter in S is a jewel? Is there any data structure you can think of that we can use to maybe look up if this particular character is a jewel in constant time? If you thought set, the answer is correct. I know I'm over here sounding like I'm Dora or something, but that's just how we're going to do this. So if we replace this loop with a set, then we can in constant time determine if the character in this string is a jewel. So we're going to go on ahead and do that. So I'm going to come up here, erase this so I have space. It would be awesome if I had a super mega whiteboard, like a super giant one like the professors use in the classrooms, but that's not what we're working with right now. So, okay. What we're going to do is we're going to create a set. And like I said, I'm using C++, so we're going to use an unordered set. And the reason we use an unordered set is because this will use a hash table as its backing data structure rather than a tree, which means that our lookups and our operations, our common operations, are going to be constant time rather than logarithmic time. So you have unordered set, and we're just going to call it jewels. All right. What we're going to do is we're going to go over the elements in J. So for int, let's say k equals 0, while k is less than j dot size plus k. And we're just going to insert it. All right. We're basically going to say jewels dot insert j of k. Now you have a set, right, that will contain the characters in J, the characters that are jewels, and we can look them up in constant time, all the characters in here. Now you want to have another loop to iterate over your string of stones. So for int I equals 0, while I is less than the size of the set of stones, right? Plus I. Okay? Now, all you need to do at this point, I didn't create my local variable to store the count, so we're going to say int count equals 0, right? So now we're going to say if s of I, so the current character that we're looking at, oh wait, hold on. What we want to do is we want to check if it's in the set. So we're actually going to do this. Let's use auto so we don't have to write out the specific type for the iterator for a set. We're just going to call it equals, and then we're going to check the set, and we're going to do a find and see if we can find the current character in that set. So s of I. Right, so we're going to take this and check the set that contains these and see if we find it. Now, find basically returns an iterator pointing to the actual location of that value in the set, or it returns an iterator pointing to the end. Basically the character just after the end or some value, which indicates that it's not in the set. So basically, if it is not equal to, well, I call this set joules. Ignore that. When I was practicing this problem earlier, I called it set. But yeah, so joules if the iterator is not equal to joules dot end, that means we found it. That means that this letter is in the set of joules. So we want to increment the count. Okay? And then we continue. And then at the end, we just return count. This marker is dying on me. You know, it's like technical difficulties during the actual production. This never happens when you practice them. But let's go over this now. So we have the joules. So we said this is size M, right? So basically in M time, we iterate over the set of joules and we store them in a set. Okay? We iterate over the string of joules in this case, and we store it in a set. And then we go through our string of stones, and for each stone, we basically check if we can find it in that set of joules. The beauty of a set is that you can do this lookup in constant time. So before we were doing, for each of these, M work. Now, for each of these, we're only doing constant work, which means that our complexity becomes O of n, right, times 1, which is just O of n. So just like that, you were able to reduce the complexity of this algorithm from O of n times m, which wasn't too bad in itself, but this is better, to just O of n. And we can actually get even better than this if we use bitwise operations. But I may save that for a later video, or maybe in the next 5 seconds you'll see me talking about it once I get a new marker. Stay tuned. And we're back. So remember, we went through an algorithm with a complexity of O n times m, where n is the length of the string of stones, and m is the length of the string representing the joules, right? And then we were able to get that down to of n complexity, right? Now, if this is sufficient, I think at an interview, you'd be in good shape if you could figure this out, but you get extra brownie points if you can do some bitwise operations, depending on the language you're using. We're talking C++ here. So we're about to do this. Now, a set is good, but instead of having a whole set, you really could just have an unsigned long, basically, that represents the set, a bit set, if you will. So what we're going to do is replace this I guess we didn't have to erase the word joules, but we will, right? And we'll just get rid of this. We already did all of this. Let's just do it again. Okay. So we're going to create a bit set. So we're going to use the auto keyword, which just basically will infer the type. And we're going to call it joules set or joule set. And we're going to make this, initialize this to just 0, ULL, it's unsigned long, which will guarantee that we're using a 64-bit number. And then what we want to do is now iterate over the joules again. So for int k equals 0, while k is less than j dot size, k plus plus. Right? Now, we are going to get the bit position of this letter. So, you can ask this at an interview, but the ASCII code for A is 97, right? The ASCII code, that's for lowercase a. For capital A, the ASCII code is 65. So, if we subtract capital A from every letter, basically if it's uppercase or lowercase, we'll get a value that falls between 0 and 64, or 63 in this case. So we can use an unsigned long with 64-bit value and assign essentially each letter to a different bit within that number. So what we'll do is we'll get the bit position and we'll say right here, and we can use an int for this. So we'll say int bit pause, and this just represents the actual position of the bit that we're going to set, right? We're going to say j of the current position in j, right? This is a little 0 in this case. And then we're going to subtract capital A character like we said. And now, after doing this, we're basically going to take our joule set and or equal it with the number 1. We'll cast that to a unsigned long as well. And we're going to shift to the left, bit pause. And we're using or because that way it'll set the bit in this number, the joule set number that corresponds to this particular number. All right? And we're just going to loop over all of these and we're just going to do that. Now, like I said, lowercase a is 97. So if we subtract uppercase a, which is 65, 97 minus 65 will give you 32. So this will be 32. We'll shift 32 bits, right? And then we'll set bit 32 in the joule set. And then we'll do the same thing for here, but uppercase a minus uppercase a just gives you 0, right? And for anybody wondering, yes, we're dealing with letters here, but because every letter has an ASCII code assigned to it, when you subtract letters from a letter from another letter, you get an integer. And you can cast it to a character if you wish, but we don't want that in this case. So, and like I said, if you have any questions, feel free to ask in the comments. I can clarify in the comments or I can clarify in another video. So now that we've set every position in the joule bit set that we wanted to set, now we can basically have another loop that will go through every position here and check if the bit corresponding to that letter in the bit set is set. So we'll say for int, let's just say I equals 0, right? While I is less than the collection of stones, right? Size I plus plus. And then we'll basically say, okay, well, what is the position going to be? Just like over here, we took it and we shifted it a certain amount. We want to do something similar. So, yeah, we want to do something similar. So we're basically going to say int, get the bitpause again, of the current character in S, once again, minus uppercase I. Right? Because we want to, this is how we mapped it to the bit set, so that's how we want to look it up in the bit set. And then we basically want to say if, and this is where, you know, it tests your knowledge of bitwise operations. If joule set, which is our, essentially, you know, our number that represents, you know, our bit set, if you will, joule set, and this is the bitwise and, not the relational and, 1, unsigned long, once again, shifted to the left, bit pause, meaning if the position, or if the bit at that particular position is set to 1, we'll close out this. And we didn't create, you know, that variable once again. So we'll do it up here, outside before this for loop. And we'll set it equal to 0. A lot of motion with this board. Okay. Then, basically if the bit corresponding to this letter is set to 1, then we want to add to the count. Because that means it's a joule. So plus plus count. Okay, let's just, you know, open and close our braces right here. And then close our outer for loop. And then we can just return. And I apologize if this marker is a little light. I'll get some better markers for my next video. Return count. And close out the method. So, you might be wondering, well, why do this when you could have just settled for using the unordered set? And the answer is, bitwise operations are pretty quick in C++, so you'll potentially use less memory if you're using, you know, an unsigned long to represent a bit set rather than using, you know, an ordered set, because then you get the overhead of a lot of other data structures that is using, you know, under the hood. So there we go. This algorithm here is also O of n, but it's more efficient space-wise potentially, and it'll probably actually be quicker, even though it's still, you know, linear time, it'll probably still be quicker in practice to actually execute. So with that said, we went through an O n times m algorithm, and then 2 O of n algorithms. Like I said, with the unordered set, if you get that down at the end of the year, you're in good shape. If you can get the bitwise operations down, you're in even better shape. Don't stress yourself too much though. Just practice, keep working hard. Fizzle the Engineer here. If you've enjoyed this at all, please like and subscribe. Share this with your friends, and I'll be back with more problems like this in the future. And if you're into games, check out my gaming channel, Fizzle the Rap Gamer. It's a featured channel on my Fizzle the Engineer page. See ya.